right, so yesterday, when you guys were doing your notes, I did the notes here too, basically. This is your like main study guide, in my opinion. Like, if you know everything on this vocab doc that I'm making, you should be in really good shape. So I added the stuff from yesterday's notes, but then I took off the words. So like what's up here is the definition, and we're just going to kind of go through each one and make sure you can see if you can give me the word. I know you just like looked at it yesterday for the first time, but the explanatory variable in an experiment, what we're looking at to test or see if that matters. Everybody know what those are called? Starts with the F. F. Factors. Oh, look at. So, for example, if I think I have some magic pill that makes you smarter, I give it to half you. People that really need that. I'll give it to half of you. I won't give it to half of you, and then we see if it actually works. So that pill would be the factor, right, Gavin? Front of the class is this way, sir. You can gaze into Sebastian's eyes later. But, levels. I just gave you the next word. Say what? You interrupted what I was saying to ask the freaking date. Levels would be like sometimes the factors have different like amounts or levels, like the best word. But let's say that I think I have this pill that's going to make you smarter, but I split you into 4 groups. And I give the first group nothing. I give the second group like a small dose of the pill. The third group a medium dose, and then the last group a big dose. Those would be like levels. So then I can compare like does the big dose actually matter? Does the small dose better? Is the medium dose better? Whatever. So factors are what we're trying to test, and levels are if you're trying to test like different amounts of that. 4 things in any experiment. So we need to compare 2 or more groups. What's that one? Yeah, it's comparisons like in there. The second one's similar. We must randomly assign subjects to a group. Randomization. This is like me summarizing your notes. We must treat both groups the same except for the one key difference that we are trying to test. So what are we doing there? Control. And then we must repeat the experiment multiple times so we get enough data. What's that? Starts with the R. Replication, actually, but repetition is the same idea. Yeah, you're repeating like the exact same. Yeah. A fake pill or dummy treatment. What's that called? Placebo. So, like, very often in these like experiments, if I'm trying to test if this pill like gets rid of headaches, I'll have to make 2 pills, the real one and then one that looks and tastes just like it. So that when I give that to the person, they don't know which one it is. Because of this next thing. People that receive a placebo very often think that they got the real one and like react as though they got the real one. It's a very real, weird effect that has been proven over and over again. What's that called, anybody? Placebo effect. But there's been tons of studies where doctors have given people like a sugar pill and they come back and they're like, that was great, thank you, I feel so much better. And it was like absolutely nothing. The subject doesn't know what treatment they are given. That's called blind or blinding. So why might that matter? Because if they know what they got, what might happen? Okay, word on the board. Placebo effect. So this way I don't know. So I'm not like tricked into thinking something happened that didn't. The idea is the subject doesn't know what they're given, so you have no bias. You have no like, oh, I got the real pill, so I'm probably gonna feel better, or I didn't get the real pill, so I'm not gonna feel better. Because that's powerful. The subject and the administrator don't know which treatment. Double blinding. So that would be that like I'm gonna administer you, the patients, a pill, and you don't know which one it is, and that's important because you you shouldn't know so that you have no bias is what's going on. But I don't know either in this situation if it's double blind. Because I could be like, I know this is the real pill, so like, yeah, you should take this. Like, really give this a shot. I think it'll work. Or if I know it's the fake pill, I could be like, yeah, you can try it. Like my presentation might impact things. So if I don't know and you don't know, that's like the cleanest it can be. Then there's like a person behind the curtain that's like orchestrating things. So they would give me a pill and tell me to give it to a person, but I don't know what it is. The person doesn't know what it is, so it's all clean and unknown and unbiased. Okay, this one. Your notes made a pretty big deal about confounding and lurking variables and the difference between them. I've never seen the AP test ask for the difference between them. They've always just asked for like one. But the main idea there is it's a variable it's like an outside force that's acting. We're not trying to test, but it's there. For example, what did I do last hour? Okay. I got two classes I'm going to compare. This second hour AP Stats class and Miss Grappy's freshman algebra class. And, I split them, or I didn't split them, but I give both classes a test on pre-algebra. Right? So who's going to do better? You guys or the freshman algebra class? You guys. So then the claim is Mr. Davis must be a better teacher. His students did better. But what's the lurking variable, confounding variable behind the scenes? Like what's really impacting that? It's not me. It's like the class you're in, right? So yeah, like in 7th or 8th grade. So that's what's really happening, right? It's like the behind the scenes thing that's impacting both. I think I've drawn this up before. If I look at the number of party stores since the year 1600, and the number of murders in America since 1600, it would go like that. So does that mean party stores are causing murders? Probably not. There's a lurking variable or a confounding variable that is making both of these go up. And what is that? Population, right? There's a lot more people here in America than there were in 1600. So that would be a lurking or confounding variable, and I don't care which you call it. Does that make sense what I'm getting at? You guys know? Yes. Okay, there's 3 types of experiments. And this is what we're going to get into practicing more of tomorrow. But just to start talking about them and put them on the note sheet. One is where I just randomly assign everything. So I think that I've got this pill that makes you smarter. So I'm going to put all your names in a hat, mix them up, pull out half the names, you're going to get the pill, the other half are going to get the placebo pill. And then I give you guys a test and we see who does better. We compare something. But it's completely randomly assigned. So that's what it's called. Completely randomized. So I'm not trying to control anything. I don't care about lurking variables. I'm just randomly split these up and we're going to see what happens. I'm going to go down to this one down here. So this third one that I got is randomized block. That's probably the hardest one for most people, and we'll spend a decent amount of time on this tomorrow. But remember stratified sampling, where you want to make sure you get some freshmen, some sophomores, some juniors, some seniors, for example, or you want to make sure you get half males, half females. randomized block is like the experiment version of that. So if I think that freshmen, sophomores, juniors, seniors might react differently to some, my smart pill, like my smart pill might work better in seniors than sophomores or something. If I think that might be the case, I'm going to run 4 totally separate experiments. I'm going to take the freshmen, and some of them get the smart pill and some don't. I'm going to take the sophomores, and some of them get the smart pill and some don't. Same for juniors, same for seniors. So a block design is just doing like multiple experiments at once, so you can separate out all the variables. We'll practice it more. And then if we're doing where the experimental units are paired up, that's called a matched pairs. Again, we'll talk more about this tomorrow. But for example, if I think I've got like a new type of mitten that keeps your hands way warmer, what might be a way that I could use a matched pairs design? This might be a little too tough a question, but we'll see. A matched pairs design to test if that mitten actually makes things warmer. Yes, compared to like your current mitten, whatever it is. On the same person. That's the match pairs. So what's the most, like if I give like Mr. Heike the new kind of mittens, and then I give Bowman the old kind of mittens, and they go about their lives, are we going to know really what, like we're going to be able to compare? So what's the most similar thing to like Heike's right hand? Heike's left hand. So we put one of the new mittens on one hand and one of the old mittens on the other hand, and we can compare. And you can very often use yourself as like your own pair. So I think that if I give you this magic jelly bean, you'll jump high. So I'm going to have you jump, record how high you jump, and then I'm going to give you this magic jumping bean. I'm going to have you jump again. And then I can compare if that changed. Because if I randomly split it up, is it possible I get like a bunch of super leaping high jumpers in this group and a bunch of people like me that can't jump at all in the other group? Yeah, and then it kind of messes things up. But if you can pair things up with something similar, which is yourself the most often, that's good. Okay. Questions on anything? I'm just kind of like summarizing yesterday, really, before I give you time to work. But questions on anything I just talked about here? So you guys should be doing homework 3, which is actually before notes 4 in the packet, if you remember. It's like flipped. And please check your answers as you're going. That's how you learn. Please ask questions if you have them.